The device tree is the heart of Automation Manager. It is where you connect, configure, and program the pack. It is also where you configure field buses and slave devices. The first node in the device tree is the name that you gave the project and is purely symbolic. The next exposes the pack itself. By double-clicking the pack device, you can see where you would both connect to the pack and configure its PLC settings. When opening up the pack device root, the device tree starts to be broken down into two main logical sections. The first is PLC logic, which, as the name implies, contains all the actual programming and determines the logical execution of your machine. Second is the physical EtherCAT network of the pack, represented by the EtherCAT_master node. In the middle is an outlier of these two groups called Soft Motion General Axis Pool. This is where users can add imaginary or virtual axes to their projects. Since it's not really programmable and it's not truly a physical slave, it literally exists between the two. Diving into PLC logic is an application container, which contains a library manager, a program or POU named your program, and the task configurator. By double-clicking on the library manager, you see all the libraries that have been added to this project. Any of the standard pack projects will already pre-populate the appropriate libraries for your pack. For instance, since this is a PAC 320-C project, it already has pre-populated with the coordinated motion and CNC libraries, as you can see here. Next, you'll note that we have a program we've named Your Program. Double-clicking it opens the program editor. In this case, it was written in structured text. This is a very basic program that sets our variable name myBool to the opposite of myBool. So if myBool is true, this program would set it equal to false. And in the next cycle, it would set it to true again. But what dictates the scan rate, and even that this program will be executed cyclically anyway?
Well, that's where we get into task configuration. Task configuration determines what gets executed and with what priority. That means if our program was not referenced in a task, it would not get executed at all.
In this case, by double-clicking main task, it reveals that our program is getting executed at a priority of 1 at 4 milliseconds per cycle. There is another task here that's called EtherCAT_master. The EtherCAT master is a special task which determines the frequency of the EtherCAT read-write bus cycle. EtherCAT_master.EtherCAT_task is the actual representation of that read-write bus. Double-clicking the task, you can see that the EtherCAT master EtherCAT task runs every 4,000 microseconds by default and is set to a priority of 0. This task must be priority 0 or the highest priority, which ensures that it does not get interrupted by lower level tasks like our main task, which is set to priority 1. There is something else that is unique. Instead of being set to cyclic, this is set to event_ECM_DC. This ties this task to a very special high precision clock inside of the pack required to run EtherCAT. Although all of this is set by default, it is worth remembering these basic rules. Do not rename or modify or delete EtherCAT_master.EtherCAT_task. Simply put, your EtherCAT bus will not run without it. Likewise, the EtherCAT_master task must be set to priority 0, and it must be set to event_ECM_DC. In summary, let the defaults for these be the defaults. Beyond being responsible for the EtherCAT bus cycle, all programs that use motion control function blocks, such as those that start with MC, or for tasks that are truly high priority, such as e-stop logic, should be referenced in the EtherCAT master task. Motion control requires tight coordination between axes. The pack uses EtherCAT distributed clocks to achieve this. If a user puts motion control in lower priority tasks, which can be interrupted, these clocks would lose synchronization. Right now, we don't have any additional programming logic in our EtherCAT_master task, so let's show how to do that quickly. By right-clicking on Application and selecting Add Object, a huge range of options come on display. This is how you would add some of Automation Manager's most powerful tools, such as Alarm Configurator, CAM and CNC editors, Recipe Manager, visualization screens, and much more. For right now, we're just going to add a new program for motion. To do so, I select POU. POU stands for Programmable Organizational Unit, which simply means something that will be programmed using the IEC languages to either be a program, a function block, or a function. In this case, we want a program to do something in the language of continuous function chart, which is the current defaults. We'll name it Motion Program for clarity. We don't want to go through the programming of CFC here, so let's just assume the program simply jogs a motor X. Right now, Motion Program is not included in any of my tasks, so upon downloading and running this application, no motion will occur. I first need to reference it in my task manager. To do so, I can simply click on the POU and drag it to my task of choice. Since this contains motion, that task of choice should be EtherCAT_master. That about wraps it up for PLC logic, but what about the EtherCAT_master and the slave network that we've been neglecting? If you're connected to the pack, you can right-click and scan to see all of your devices that are on the slave network. If they're on your machine network, in all likelihood your intent is to program them, so we'll import them all into our project. The PAC 320 bus coupler is a representation of the eBus or EtherCAT bus connector on the side of the pack. Thus, any PAC I/O directly connected to the pack will appear here. You can think of everything below the EtherCAT_master route as all devices that are connected from the X1 RJ45 EtherCAT port from the front of the pack. In essence, the organization of the devices listed here match the order of the physical network it's representing. Thus, I have 3 PAC I/O units hanging from my pack, starting with the 16 in and 16 out unit. And I have 2 P-series drives connected via Ethernet cable. I can now rename my motion access so I don't get the two mixed up. In addition, I can double-click my PAC I/O, go to the EtherCAT mapping tab, and name my I/O for later use in my program. Both axes and EtherCAT map variables are global, so that means they can be used anywhere within my PLC logic branch. That about does it for the device tree. Of course, this video is not all-inclusive, but you should have a much better understanding of not only how the device tree works, but how Automation Manager is designed to give the programmer complete control of how and when things execute.